Okay, I'm just doing a short video on the ultimate GPS breakout board from Adafruit Industries. This is a breakout board based on the MTK 3339 receiver. As you can see, it's all pre-mounted. All you have to do is mount the pin header if you want to, or you can solder the wires direct to here. You've also got a battery clip. Now the battery itself is not provided. It's not really required unless you want to keep the hot time on the unit. By the hot time I mean it keeps a real-time clock running within the unit. There's no real need for this at all in most general day-to-day applications. Okay, the board itself is based around the MTK 3339 receiver, as we can see here. It's pre-mounted and mounted on the board, so there's very little for you to do other than solder the headers on if you require them. There's some people just solder the wires direct onto the actual connections themselves, keep the profile nice and low, and the battery clip for mounting onto the back of the unit as well. The battery clip's not necessary, as the unit will run without it. All it will give you is the ability to have the real-time clock running on the unit when it's unpowered. Now the output for this is 5 volt, so if you want to use it with a Raspberry Pi, you will need a logic level shifter to convert the signals down to the 3.3 volt. The device runs at 5 volts, takes around 20 milliamps when it's got a lock. The unit has an internal antenna, so there's no requirement for you to use an external one, though it does have a micro FL connection if you do choose to use one. For instance, if you're mounting this under the bonnet of a car and you require the antenna to be mounted on the dashboard or an aerial antenna of some type. Now when the unit is doing its search, there's no output from the RX and TX lines, which incidentally run at 9600 baud, and output the standard NMEA messages from the satellites. The PPS, or pulses per second, will pulse once per second once it's got a lock onto the satellites. You can use that, for instance, if you were running an Arduino, so that it's not trying to look for information on the serial port when there's nothing there. It'll only actually read once that pulse actually starts going. The unit can go up to 60,000 feet, that's 1800 meters, before it will lose its ability to log onto the signal, and it will also track itself up to 515 meters per second. The reason it won't track over this, for instance if you're in an aircraft, is it's an American company and they've got restrictions on what they can actually put out for military use, if you like. This unit as well has a 66 channel receiver, which means it can lock onto up to 22 satellites. Now that will give you an incredibly accurate reading. Outputs at 10 readings per second, which is more than adequate for somebody jogging or even driving in a car, to give them a nice accurate location as to where they are. The easiest way to try and narrow down the location from a 10 meter radius, which the module will give you, is to make multiple readings, say 20, 30 or even 40 readings, and then work out the average based on the coordinates from there. And I've heard people getting as low a resolution, or sorry, as high a resolution as half a meter with these things. Okay, well that concludes the short video on the ultimate GPS breakout board from Adafruit Industries.